Good day, everyone. I'm here to share to you the idea about belts. Belts. It is an essential component of many mechanical devices transmitting power and motion from the driving shaft and pulley to the driven pulley. Meaning, it is a flexible mechanical element used to transmit power between rotating shafts to typically to the pulleys. Power transmission system, especially when shafts are relative far apart or when smooth, quiet operation is desired. The basic principle, it is operates on friction or positive engagement, like in timing belts. The belt wraps around pulleys mounted on the shaft as one pulley rotates the driver. It moves the belts, which in turn rotate the other pulleys, the driven. So the common types of belts, there is a flat belt, V belt, and timing belt. Belt is cost effective and easy to maintain, absorb shock and vibration, protecting machinery. It is a quiet operation compared to chains or gears. It is allow for slip, which can be a safety feature in overload condition. For design consideration, the belt system must consider power to be transmitted, shaft distance and alignment, their tension and speed, environmental conditions like dust and temperature. Mechanical belt originates from way back when humans employed rudimentary cords for transmitting power between pulleys in Asian civilization back in 18th century. So, in early civilization where simple ropes or cords were used to transmit water between rotating shafts or pulleys, often in water lifting device or primitive weighing machines. For the lift came during the Industrial Revolution in the late 18th century when belt became essential for transmitting power in factories. For flat belt leather belts, often made from cowhide, cowhide, were used to connect steam engines to machinery across long distance. These belts were quieter and more flexible than gear or shafts, making them the ideal for the sprawling layouts of textile mills and workshops. Here is the fundamental of belts. What is the basic parts of belts? The first term is belt. Power transmission occurs through a flexible element. A belt is a flexible loop, typically made of rubber, fabric, or synthetic materials that transmit mechanical power between shafts. So pulleys, rotating elements wrapped around by belts fairly tightly underneath normally. So pulley is a wheel with a groom wheel designed to hold the belt in place. The driving pulley connects to the power source like a motor, while the driven pulley connects to the component receiving power. Pulleys determine the speed ratio between the input and output shafts. Smaller pulleys spin faster, larger ones more slowly. So here's is the shafts axle on which pulleys get mounted fairly rigidly underneath machines. So it is a rigid, shapely components that rotate and support pulleys. One shaft is power driving and the other is torque driven. Shafts are typically supported by bearings and elements to minimize energy losses. Here is the diameter. The pitch circle is essential size of pulley where belt engaged tangentially with considerable friction frictional force normally. So diameter, it refers to the size of the pulleys. The ratio of the diameter affects speed and torque transmissions. Down then, the center distance. Distance between center of two pulleys is measured quite accurately under normal operating conditions, pre- preferably. So center distance is the distance between the center of two pulleys. This affects belt tension and alignment, and the belt may not fit too long, and the belt might sag or slip. So the third one is slip, relative motion between belt and pulley, leading sometimes to considerable power loss under certain operating condition. Unfortunately, slip occurs when the belt doesn't move in perfect sync with the pulley, causing a difference in relative motion. This reduces efficiency and can affect speed accuracy. Flat belt and V belt experience more slip than two or timing belt, which are designed for precise synchronization. So here, the last is the tension, refers obscurely to force exerted vigorously by belt on pulleys for maintaining sufficient contact and transmitting considerable power. So tension is the force pulling the belt tight between pulleys. It must be high enough to transport power without slipping, but that it strain the belt or pulley bearings. Tension can be adjusted manually or automatically using tensioners. So here we have the two types of belt connection, the open belt and the cross belt. The open belt is the configuration. The belt runs in the simple loop with both pulleys turning in the same direction. As we can see, the slack slide, the upper slack slide, and the lower is the tight side. This is the driving pulley, and this is the driven pulley. The purpose is when you want to do the driver and the driver shaft to rotate the same way. A common use in fans, pumps, or conveyor system where synchronized direction is required. The pros of this is simple to install. Just wear on the belt since there is no twist. So the limitation is slightly more prone to slip compared to cross belt. The right here is the cross belt. The belt is twisted in figure 8. So you can see the number 8. You see the number 8 like this. The 8 figure causing the pulley to rotate in opposite direction. The purpose is when you need the dribble shaft to rotate in the opposite direction of the driver. It common use in textile machines or where reversal is essential without changing the mechanism. The advantage of this, more contact area between the belt and pulley, better grip, and less slip. The limitation, increased wear due to the twist, not suited for high-speed application because of the sharp bending. So the third slide is the uses of belt. There are three types of uses of belts. The first one is power transmission. Mechanical system transfers energy between rotating shaft in belts quite efficiently with considerable flexibility and relative ease. So, in power transmission, belts connect one spinning part to another, like a motor to a machine. When the motor, when the motor turns, the belt carries that motion and make the other part move too. Think of how a bike chain works, but smoother and quieter. So the conveyor service in Philippines are done and incorporated. They provide a conveyor machine and processing belts along with consultancy, installation, and maintenance service. So in factories or airports, Belt move things from one place to another, like boxes, packages, or even your luggage at the airport ride on these belts, like a flat moving round road. Um, the third one is the elevator service in Philippine Access Lift and Electronics Corporation, specialized in elevator repairs and maintenance, handling even the toughest problem with experienced personnel. So belt helps elevator go up and down. They connect the elevator car to a motor system. When the motor turns, the belt lifts or lower the car safely in the maintenance problem. Here we have the three types of transmission belts. Flat belt. Flat belt are power transmission belts that are flat and made of rubber, synthetic composite, or leather. So flat belt is like a ribbon, flat and wide. It runs smoothly over flat pulleys and was common in older factories. It is quiet and good for low, moderate power over long distance, but it can slip more easily if it's not tight enough. So bead belt often drive various engine accessories like air conditioning, compressor, and alternator rapidly on many automobile engines nowadays with great efficiency. So V belt, it is like a shape like a V in cross section. This belt fits into matching V-shaped grooves on pulleys. That shape gives it better grip and makes it great for high power, high speed machines. You'll find V belts in things like car engines and move logs, lawn mowers. So tooth belt is known as timing belt or cudgel belt. It is a flexible belt with teeth molded onto its inner surface. So tooth belt or timing belt, this one has a tight teeth. Okay. This one has a teeth on the inside which fit the perfect into matching grooves on the pulley. That makes no slipping at all. It keeps parts turning in sync. Super useful for engines where precise timing is critical, like in your car camshafts system. So in summary, flat belt is smooth and simple. V belt is strong and gripful. And tooth belt is precise and no slip. Here we have the flat belt. Usual flat belt materials. There is leather, rubber, stitches, canvas, and balata. So leather, one of the oldest materials, it's strong, flexible, and grips well, which helps reduce slipping. So rubber belts are elastic and can also shock, which protect machines from sudden jerks. So stitches canvas are made by layering and stitching fabric, making them both strong and lightweight. So balata, less common. Balata is a natural rubber-like material. It is water resistant and doesn't conduct electricity. So it was ideal in setting where safety was a concern. So here is the advantage of flat belt: high speed drives, dusty and abrasive environments, long distance between shops, high efficiency, low cost, and low maintenance. So high speed drives, flatbed are lightweight and flexible, so they can run very fast without generating much heat or stress. So thus the innovative environments. They're flat, open design means they don't drop dust or grip easily, and there's no need for close fitting parts like gears or chain. So long distance between shock because they are so flexible and can be made very long. Flatbeds are ideal for connecting machines that are far apart. So high efficiency when properly tensioned and aligned, can belts have less bending and friction loss compared to feed belts. That means more of the power actually gets to efficiency can reach up to 98%. So no, so cost effective, low cost and low maintenance. They're simpler to manufacture and install, and don't need constant lubrication or adjustment. If one wears out, replacement is cheap and quick. So here's the limitation about flat belt. It's a disadvantage: noise, slippage, limited speed, and quick wear, and alignment issues. So the first one is the noise. At higher speeds or under heavy loads, flat belts can slap or flutter or creating noticeable sound, especially if the tension is not perfect. So slippage, since they rely on friction, any drop in tension or weight, wet or oily pulley can cause the belt to slip, reducing performance. Um, limited speed. Plasmids are not ideal for carrying heavy loads, so they can stretch or too much compared to toothbrush or chain. Frequent wear. Um, Friction-based systems tend to wear out faster, especially if exposed to measure heat or misalignment over time. Alignment issues: if the bullets are not perfect line up, the belt can wander or come up entirely. The belt belts are more sensitive to this than belt which stayed in their groups. So here's the belt. So flat belt design formulas. Flat belt design formulas. The belt tension ratio is the ratio of tension to the tight side to the slack side of the belt. So here is F1, F sub 1 minus F sub 2 all over F sub 2 minus F sub C equals to E raised to F times theta. So F sub 1 is the force on the tight side, and the unit will be Newton or pound. So then F sub 2 is the force on the slack side. The unit will be Newton or pound. So F sub C is the centrifugal force. The unit must be Newton or pound. So the E is the Euler's number value of 2.71. Yeah. The F is the F is the friction coefficient of friction. So the theta and the angle of contract, the unit must be radians. So here's the centrifugal force. Centrifugal force, the outward force due to belt rotation, reducing effective tension. For English unit, F sub C equals to 12, density, density B times T times P raised to 2 all over to G equals to density times P times T times B raised to 2 all over 2.68, while the SI unit F sub C equals to 9.81 times raised 10 raised to negative 6 density times B times T times P raised to 2 all over G. FC equals to uh, W times V squared all over G and R. So the PE here is the density, but the belt density, the unit must be kilogram per cubic meter or pound per cubic inches. So the B is the belt wind. The unit must be millimeter or inches. So the P is the thickness, the belt thickness. The unit must be millimeter or inches. So the FC here is the centrifugal force. The unit must be Newton or pound. So the V here is the belt speed. The unit must be, so it's like a velocity. The unit must be meter per second or feet per second. So the G is the 9.81. The gravitational acceleration. The unit in meter per second squared or feet per second squared. Feet per second squared. The W is the belt weight. The unit is Newton or pound. So the R is the radius of pulley. The unit is millimeter or inches. So here we have the effective belt pulley. Effective belt pulley is the net force transmitting power. So sorry. F sub 1 minus F sub 2 equals F sub 1 minus F sub C times 2 E raised to F times theta. It's enough. Let's arrange this. So let's arrange this first. Uh, to avoid the confusion. So here we have the E, the rational unit number raised to F completion fraction times theta minus 1 all over E raised to F times theta. So the F is the force on tight side. On the tight side, the unit is Newton or pound. So the theta here is the angle of contact. The unit is rad. So the F sub 2 is the force on the slack side. Uh, so remember everyone. So F sub 1 is the force on tight side. F sub F sub 2 is the force on slack side. So F sub C is the centrifugal force. Unit must be Newton or pound. So the F is the coefficient of friction, meaning no unit because it is a coefficient. So the angle of contact right here, the theta equals to 180 degrees plus or minus 2 sine raised to negative 1 times d sub 2 minus d sub 1 all over to 2c as open belt connection. So down then is the theta equals to 180 degrees plus 2 sine raised to negative 1 times to d sub 2 plus d sub 1 all over 2c as cross belt connection. So theta, the angle of contact degree, the unit is degree. So d sub 1 is the larger diameter, or the unit is millimeter or inches. D sub 2 is the smaller diameter, millimeter or inches. So the C right here is the center distance. The unit is millimeter or inches. On the next slide, the art of contact for open belt connection is sub 1 equals to R sub 1 times theta sub 1 S sub 2 equals to R sub 2 times theta sub 2. For small pulley, the difference is for small pulley, only one here right here. The sub for larger pulley, it's only two right here. So for small pulley is sub 1. This is a art of contact of small pulley. So the R1 is radius of the small pulley. So theta sub 1 is the angle of contact for small pulley. So this sub 2 is the art of contact of the large pulley as rad unit. R sub 2 is the radius of the large pulley as millimeter inches. Theta sub 2, angle of contact for small or large pulley. So as in cross belt connection, it's same. If, if the problem have if the problem have open the connection cross belt connection, we can use this. It's the same formula. So power transmitted P equals to F minus F sub 1 minus F sub 2 times B. The F sub 1 is the force on the tight side, the F sub 2 is the force on the tight slack side. So the B is the belt speed, the P is the power, the unit is horsepower. So the cross sectional area of the belt. A e- uh, A equals to P over B S sub W minus density P, B squared over G times 2E raised to F times theta minus 1 all over 2E sub re raised to F times theta. So the A is the cross-sectional area of Total area. The unit is millimeters squared or inches squared. So the SW right here is the working stress. The unit is MPa or PSI. The MPa is megapascal. The PSI pound per inches squared. So the B is belt speed. The unit is meter per second or feet per second. The P is power transmitted kilowatts or HP. Same is in this HP or kilowatts. So P is the density of the belt, kilogram per cubic meter or feet uh, over uh, pound per cubic feet. The G is 9.81. The gravitational acceleration meter per second squared or feet per second squared. I think the reduce the angle of contact rad as unit. F is the quantity of friction. The next is the belt length. Open belt connection. The L the L equals to pi over 2 minus um, over 2 times d sub 1 plus d sub 2 plus 2c plus d sub 1 minus d sub 2 raised to both are raised to squared all over 2 4 c, while the cross belt connection L equals to pi over 2. So d1 d sub 1 plus d sub 2 plus 2c plus d sub 1 plus d sub 2. Both are raised to 2 all over to 4c. So as we can see here, the difference is the integers in diameter. The cross belt is plus, the open belt is negative. Negative. Yeah, it's negative. So belt speed is v times pi times p sub 1 times speed. As a speed sub 1, and then d equals to pi d sub 2 diameter. and times speed as n sub 2. If the percentage slip is given to the problem on the problem, b equals to pi. So pi times d sub 1 times n speed sub 1 times to 1 minus percentage of slip, and then just like this. So b equals to pi times t sub 2 times n sub 2 in the derivative. This is in the derivative, that's why it's plus. So 1 plus times 2 equals to. So, so here we have the V belt. V belt usual V belt materials is rubber, polyurethane, as P2, Noriprin, Kevlar, or aramid fibers. Using rubber is a classic choice. Rubber is flexible, affordable, and breaks fully well. The polyurethane, as PU, is tough and resistant to chemical, oil, and wear. It's great for precision, equipped in a place where the environment is harsh. So neoprene are resistant to heat, oil, ozone, and aging, which is why they are used in vehicles and industrial machines that run hot. So Kevlar or Rabin fibers, these fibers are incredibly strong and don't strip easily. They keep the belt tight and prevent from slipping or snapping under high loads. So the V-belt advantage: high grip, efficient, efficient power transmission, low maintenance, noise reduction, space efficiency. So the high grip, it is let the belt wedge firmly into the pulley grooves. It will increase friction and means less slipping and better traction. Efficient power transmission. V-belts can transfer more torque with less slippage than flat belts. That means the power from the motor gets used more effectively. Low maintenance, was properly installed. This V-belt no need for frequent tightening or lubricating like chain or gears. Noise reduction. Um, for V-belts, it runs smoother and quieter at moderate space efficiency. It allows them to fit in tight sight while still transmit significant power. So this is the disadvantage of labels wear and tear. Friction is great for grip, and also it leads to material fatigue over time. Heat, dust, or oil can make them crack, fray, or lose shape. So if it, so efficiency losses is some power through slight slippage or flexing under load. Timing timing belts are more precise when every second counts. So regular inspection needed. Small crack or looseness might not show up until performance dips. That's why routine checks are needed to spot problems early. Replacement challenge. Some machines, worn belt is not easy. It need to remove guards or nearby parts. Keep the belts buried deep inside. So the last one's the limited speed range. At very high speeds, belts can flutter or heat up, especially if the tension is not right. That can shorten their lifespan or cause unexpected slippage. So here's the formula for B belt. as the ingredients. Iba yung ano yun. So, bed tension ratio, the F sub 1 is force on tight side, minus F sub 2 is force on slack side, um, force F sub C, and regular force. This F or this force is the unit is Newton or pound. The theta right here is the angle of contact, the unit is rad. So the F is the coefficient of friction, no need of unit. This is ship angle, one half of ship angle. Then the unit is degree. Sorry, the E is unit number 2.71. Sorry. Effective bell pull, F sub 1 minus F sub 2 equals F sub 1 minus F sub C, the rational number times raised E raised to F times theta over sine sub A times sub angle minus 1 all over E raised to F times theta over sine times sub angle. So the angle of contact is the theta. The unit is rad. The F sub 1 is the tight side. The unit is Newton or pound. The F sub 2 is the force on slack side. The unit is Newton or pound. The F sub C is the centrifugal force. The unit is Newton or pound. So, F is the coefficient of friction, only the unit. The ship angle is one half of ship angle. The unit is degree. So these are this is the rated horsepower for standard size A, B, C, and E. So rated HP horsepower equals to power constant of A times to 10 rate 1000 over V sub M. V sub M is belt speed. Unit is speed per minute. Um, Open parenthesis. Uh, Raised to 0.09 minus C over sorry A sub D sub 1. C is the C right here is the have constant of have a constant of the constant of 13.9, the constant of the C right here is have a constant of 13.962. So the A right here have a constant of 4.737. So minus E. The E right here is the 0.0234. So the K sub D is the small diameter factors. So the BM square speed, 10 raised to 6 millions, 10 raised to 3 is 1000. So rated horsepower per standard size of B only. So rated HP equals to A, the 4.737 is the value of this. It is a have a constant of a constant value of 4.737, and the C right here have a constant value of 13.962. This one, the E, have a constant value of 0.0234 as standard size of B only. So the BM is the B sub M is the um, These three are AC and E is the power constant. And the unique the unique constant value. In the next line, adjusted rated horsepower. Adjusted rated horsepower is equal to K sub theta times K sub L times rated HP. So the K sub theta is the arc contact factor. So the K sub L is the length correction factor. Here right here is the design horsepower. So design horsepower equals to power transmitted times to N sub SF. So the power transmitted is um, right here. This is the power transmitted. This is the power transmitted. P equals to F sub 1 minus F sub 2 times the belt speed. Belt speed. So the N sub SF is the service factor. The number of belts right here is the N sub B equals to design horsepower all over to adjusted rated HP. So the belt length, this is the belt length, the open belt. For the open belt, L equals to pi over 2 times d sub 1 plus d sub 2 plus 2 times c plus open parenthesis square root of d sub 2 minus d sub 1 all over to 4c for cross belt. L equals to pi over 2 open parenthesis d sub 1 plus d sub 2 plus 2 times c plus d sub 2 plus d sub 1 raised to 2 over to 4c. So the difference is the integers of diameter of large pulley and small pulley. For open belt, it must be 2. It must be, for the open belt, it must be negative integers. For the cross belt, it must be positive integers. For tooth belt, usual materials, for tooth belt, usual materials be, sorry, belt. All this for tooth belt, usual tooth belts. Tooth belts materials is a rubber, polyethylene PU, as PU, urethane, Kevlar or ceramic fibers. Steel reinforced belts. Rubber, it uses rubbers. It can mold precisely to the tooth shape needed. Polyurethane as PU are very resistant to wear, oils and chemicals. Neoprene adds heat, oil, and also resistant, making tooth belt more reliable in industrial environments where conditions can get extreme. Kevlar fibers. These are super strong fibers are used as tensile cords inside the belt. Steel reinforced belts are used when ultra high strength is needed, like in heavy machinery or racing engines. This is the advantage for foot for tooth belts. High torque capacity, no leakage, no noise and vibration, no lubrication required, consistent speed and last the consistent speed transmissions, high torque capacity because it matching works on the pulley, so the belt can handle more force without slipping, no slippage because of the positive engagement between the tip and the pulley. There's no room for slippage even under heavy loads. No noise and vibration. They run smoothly and quietly because there is no metal contact. No lubrication required. Toothbrushes don't need oil or grease. That means cleaner operation and less mess in maintenance. Resistant speed, transmission. The bed cannot sleep. The driven part stored in perfect sync with the driving pulley. So this is the limitation of tooth belts: higher cost, complex design, limited flexibility, no overload protection, replacement challenge, higher cost because are used best tooth belt made with precision materials like glutarate and reinforced fibers. So they can cost up more up front than basic belts or flat B belts. Complex design, the system is teeth aligned perfectly with the pulley groups. Limited flexibility because of their tooth structure. They don't bend as easily around tight curves or small pulleys. No overload protection. It sometimes jam or the loop suddenly spikes. The tooth won't slip. They snap or strip instead. Replacement challenge. Changing a tooth belt can be tricky, especially in engine or closed system where the timing has to be reset precisely. Here is the formula of tooth belt. The belt length, the open belt, is the pi over 2 times d sub 1 plus d sub 2 plus 2c plus d sub 2 minus d sub 1 raised to raised squared all over to 4c for cross belt. L equals to pi over 2 times d sub 1 plus d sub 2 plus 2 times c plus um, d sub 2 plus d sub 1 open parenthesis raised to squared all over to 4c. So d sub 1 is the diameter of the small pulley while the d sub 2 is the diameter of the large pulley. Both are mm or inches depends on the unit. The L is the length of the belt. The unit is millimeter or inches. The C is the center distance, millimeter or inches too. So the bed speed is uh, B equals to 5 times D times speed all over 60. V is the bed speed, meter per second or feet per second. The pi is 3.14. The diameter width is mounted width is are mounted on the shafts, you know, which uh, diameter which they are using the D right here is the diameter of the driving pulley, that pulley attachment to the motor. So 60 is a revolution per minute. We need to convert to we need to convert to seconds. That's why 60 the unit of 60 is second. So power transmission, the P right here is HP or kilowatts. The T right here is the torque, kilonewton times meter. The W right here is the omega as angular velocity. So the tension ratio right here is the T sub 1 plus to T sub 2 raised to E raised again to coefficient friction times theta. T, T sub 1 right here is the tight side tension, but the T sub 2 is the slack side tension. Is the units number, coefficient friction, the right here is the next slide. On the next slide is next lagging. The next slide is the application of belts. So for automotive industry, um, belts are for automotive industry. It manages everything from engine timing to running the alternator, water pump, air conditioning, and more. It delivers precise movement without slippage. It operates quietly and smoothly. It can handle high speed and high temperature environments. So, industry machinery, in factories, belt powered drills, nuts, conveyors. It allows flexible layouts even with machine far apart. Can run at high speed with high efficiency. It does not require lubrication like chain keep things clean. For agriculture, farm machinery like tractors, police, harvester, and pressure depends on belts to drive mixer and conveyor components. It can withstand dusty, dirty outdoor environments. It can absorb shock, protecting machine from rough terrain. It is relatively easy to replace in the field. So HVAC system, HVAC standards heating, ventilation and air conditioning. Since HVAC have a power blowers, compressor and fans, it operates quietly for indoor comfort, require minimal maintenance over long hours. It can transmit power efficient in tight space. So I have a few questions. I have a five sample problem. Problem number one right here. What horsepower is to be taking off the driven shaft from open belt drive operate under the following condition. Driving pulley 84 inches in diameter. Driven pulley is 48 inches in diameter. Speed of the driving pulley 150 RPM. Total tension the tight side of the belt 300 pound. Apologies. Total tension on slack side of belt 50 pound. The hint answer is horsepower power equals to 25 horsepower. Let's solve this. So the given problem, so the given, so the given is V sub 1 is the 84 is the driving pulley, 20 inches, and V sub 2 is the 48 inches. The speed is 180 revolution per minute. F1, F sub 1 is the tight side. 1, the 300 pounds. F sub 2 is the 50 pound. So the unknown, the required is the first what will be the power must be in horsepower HP. So it is an open belt. It mentioned that it is an open belt. Diameter is of 1, 4 inches, is of 2, 48 inches. The speed is 180 revolution per minute. F sub 1 is 300 pound. F sub 2 is 50 pound. So let's come up with the solution. So So it needs requires the power. So we will using a power transmitted formula with bed speed. We can combine. We can integrate it. This is the formula. We can integrate it. There is a 33,000 feet pound sub force over minute because it is a English unit. Um, 1 HP equals to 33,000 feet, feet, feet pound sub force over minute. So let's put the value in the variables like that. 84. We must get the 84. So 84 inches because 84 inches. um, for bed speed, those driven pulley because it is attached the driven pulley to its driven shaft. That's why we must consider it. That's why we must consider it than the 48 follower. This one it starts right here. That's why it was all right here with the diameter of driving pulley before after this diameter of polymer pulley. So 84 inches. It must be feet. So we need to convert to 1 feet to 12 inches. Because we need to cancel this feet, pound cancel, inches, minute. HP will be leaving right here. HP will be the left out. So then we will use a calculator. Use a calculator. 300 300 minus 50 difference is that times 5 times 84 inches. Convert it to 1 feet to 12 inches times the speed of the minute plus this 3,000 that's 24.98. We need to round up to the whole value. Will be 25. That will be 25. So the answer is power is 25. Same with the hint. Same with the clue answer. 25 horsepower. Problem 2. The double ply leather belt transmitted horsepower from a motor with a pulley of 8 inches in diameter running at 17 revolution per minute to a 24 inches. Um, from a motor with a diameter pulley, the difference in tension may be taken as 20 pounds per inches of belt width. Belt thickness is 0.2 inches. Calculate width of belt. So it is. I assume it is a open belt because both belts rotate in same direction. Unlike the cross belt, it is opposite direction. So the hint right here is the width of belt is equals to 4.63 inches. So let's bring down the process. The or the given is power is 10 HP. The, the driven pulley of its diameter is 24 inches. The driven pulley of its diameter is 8 inches. The difference forces is 20 pounds. Difference tension, of course, 20 pounds. The this n sub 2 different per minute because the speed at 17 running at from a motor with a pulley running up it's running up to the 8 inches of the pulley. Let's get the so because D2 is the driven pulley is the size of the driven pulley is lower than the driving pulley. Driving pulley is bigger. It is 24 inches. We must gonna put our 7 speed into 8 inches driven diameter. So the thickness is 0.2 inches. No, 0.2 inches the bed thickness. So the required knock noon, the belt width. So I assume it is open belt. It is the this is the representation. No visible. Visible power. Mm, this is the no. This is in sub 2, the 170 per minute. This is with a driven pulley. The solution is a are transmitted with belt pulley with belt speed. What I mean, are transmitted with belt speed right here. Again, 1 HP is equal to 33,000 feet pound sub force over minute. We use that because the unit in the problem is English. So, but yeah, so let's put the value in the value for the variables. We put belt width into of course into the difference of tension. It connected, the belt width. Findings is the belt width, but is the answer for belt width. So we put in this. If we solve this in the calculator, it will give us 10 HP. Oh my 10 HP. Uh, 20 pi times 8 times 1 over 12 times speed. It's lagging, I'm sorry. 33,000. 1 HP equals to 33,000. 8 times pound sub force per minute. So the answer, oh wait, I forgot the that width. Chips up. That will give us a 4.63. So 4.63, we must consider 4.63 as the engineering decimal. Um, the answer to blood speed is 4.63 inches. The unit analysis can it is inches. Could be inches, yes. 0.2 could be inches. Cancel, 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 cancel. Use HP, but we must neglect it because the unit of belt width must be inches, so we must assume it's inches. So the third problem, compute the centrifugal force for leather belt with the following given W is the width is the value millimeter, the thickness is 6.4 millimeter, the belt speed is equals to 18.3 meter per second. Note that the density of the leather belt is approximately 0.035 pound per uh, pound per cubic inches or 974 kilogram per cubic meter. So the hint answer is centrifugal force equals to 109 Newton. So let's solve this. You must put a given. So the width 100 millimeter. The thickness is 6.4 millimeter. The belt speed is 11.3 meter per second. Density 0.035 pound over cubic inches or 1.74 kilograms per cubic meter. So the value here is SI unit. So we neglect this 0.035 pound per inches with cubic inches because it is a English unit. The given is SI unit, so we must consider this 974 kilogram per cubic meter. So required centrifugal force. Solution. The formula we will use this is the centrifugal force formula as SI unit because the given value is SI unit. We put it right here. So so let's bring down let's change let's transfer the value to the variable. So let's 0.74 6.4 times raised to negative 3 meter. We convert it to m to millimeter m to that will be 1000 over 1000 right here. That's these two. And then the belt speed is 0.3 meter per second. With open parenthesis raised to squared. Why there is a squared here? Because we need to cancel this meter per second squared. Cancel, cancel, then cancel, cancel. It needs to kilogram meter. We need to have a kilogram kilogram meter to become a newton. So if we put it in the calculator 9.74 9.74 sorry 6.4 is to the millimeter. Now 1 millimeter 1 meter to millimeter is 1, or equals to 1000 times 200. 1 times, in parentheses, 8.3. This is the belt speed. Is to 2. Oh, this, sorry. Yes, that is too much error. Is to 2. 9.81. The gravitational, the gravity acceleration as a unit. Wait. 9.81. Fine. Meter. Millimeter. Is bunch. Oh, it's right. It is right. It is right. It is right because cancel, 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 cancel. That would give us a 2.28 kilogram. So this is the but this is before that this is the representation of rotation. That's a centrifugal force. Given speed, one moving in this density. The wind of 1 millimeter. The thickness of belt 3.4 millimeter. 6.4. But we need to convert this to Newton. 1 kilogram to Newton, that will be 1.81. Calculator times 1.81. Wait. 1.81 number 1 kilogram. 108.75, but we want a whole number. That will be 109 Newton. We are right. We are right. Same with the infant. On the from the number 4, 914 millimeter driving pulley and 1219 millimeter driving pulley are arranged on the 3 meter centers. The output of the driven shaft is 84 horsepower. The belt speed is assumed to be 1280 meter per minute with a coefficient of friction of 0.30 and a slip of 1.5%. Each pulley determine the speed of the driver. So the given answer, the hit answer is the B sub driver equals to 21.66 meter per second. So let's solve this. The given B sub 1, the driver pulley, B sub 2, so 19 million, B sub 2 million, the weapon is driven. Center distance is 9 millimeter. It is 9 millimeter, right? 9 millimeter, and sorry, it is 3 m. Center distance 3 meter. So 3 meter, power is 84 HP. That'll be the belt speed from 82 meter per minute. The slip is 1.5. 1.5 5%. It requires the speed of the driver. Speed of the driver. Speed of the driver. Driver. This is the representation of that problem. River pulleys. 140 millimeter. Driven at 190 millimeter. Right here. Center distance is 3 meter. Uh, let's put an arrow. Put an arrow. The power is 84 HP from the driven pulley. So driven pulley. The driven speed is in the between the driver and driven pulley. Incorporated with the minute. The force conversion is 0.32 right here. We're putting in a given. We're gonna given. So the solution. Yeah, we use the percentage slip formula as the driver. We put the value with the variable. Like that. So cancel. Leave us a revolution per minute. Revolution per minute. Let's check if the answer is correct. 452.6. 5 times. So 1.219 converted F to millimeter divided. Or should I say like this? 1 meter over 1000 millimeter. Yes. Times 1 times 1 minus the percentage slip 1.5 divided by 100 to remove the percent. The slip salt is the verify. Wait, what about 1.292? So for checking the answer is wrong. We will change it. The answer is 3.39. That's why you need the calculator to check. 32. Remove this. Change it. And we will use a belt speed. The speed will be V equals to pi times D times N. Um, okay. So this is the value. So let's transfer the value to the variable. So we look like that. So 12.19 meter because of conversion. 1290 millimeter converted to M divided by 1000. So it's solved using calculator. Pi times 2.19 0.914 times 22. We need to convert to second. That's why there's a 1 minute per second, 60 seconds. We need to convert minute to second because the volume for belt speed must be meter per second. 60. That will give us a 16, 16.19, 16.19 meter per second squared. So the answer 16.19 meters squared. The heat right here is wrong. Heat right here is wrong. That's why you need the calculator to check on it. So you got the right formula, but the answer is wrong. But checking your calculator, you can change it to into the right answer. This is that will be 16.19. Do some checking using calculator. So the last problem. Compute the surface velocity of pulley 18 inches in diameter mounted on a shaft running at 350 revolution per minute. The given hint, the given hint for the answer is velocity equals to 16 to 49.34 feet per minute. So let's solve this using our calculator for checking. So the diameter is 18 inches. That's the diameter of the pulley 18 inches. The speed is 350 revolution per minute. Same. Required. The required answer. It should be velocity. The representation. And this is the pulley. 80 inches on it. With a speed of 350 revolutions per minute. So the solution. When there's a problem, there's a solution. Using a belt speed formula. Pi dn. D equals pi dn. Diameter and the speed. So let's put the value in the variable. So pi 3.14 times 18 times inches times 1 feet to 10 inches because the answer must be feet per inches. So we need to convert it to 1 feet to 10 inches to remove that these inches, these 2 inches. So times 350 revolution per minute. Let's plug in the calculator. So pi 3.14, 3.14. So pi again times 18 inches times feet per minute, feet per inches, 1 over 1 times the speed revolution per minute. That would give us a 16.49.34. If right here, it is same. It is the same. So it is right. So that's the idea of bells. Thank you. I say thank you because thank you for listening, and everyone take care of yourself, and goodbye.